Hello friends, welcome back to my channel Chemistry with DB. So in this video I am going to talk about a continuum of ionic and covalent bonding in various compounds. Now at A levels we are supposed to be able to understand that ionic and covalent, it's not like these are just the two extremes. You can consider these as black and white, but all compounds cannot be either ionic or covalent because there are all sorts of gray shades of gray in between. So that's what I am going to explain through this video. Now, this is the kind of continuum we are talking about. There can be compounds which are 100% ionic or 100% covalent, and there can be compounds which are mainly ionic but some covalent character, or mainly covalent and still being slightly polar. So the two main types of bonds we understand are ionic bonds, which are due to the strong electrostatic attraction between the oppositely charged ions, and covalent bond forms because of the electrostatic attraction that the nuclei of the two atoms have for a shared pair of electrons. Now the continuum arises because of the differences in electronegativity values between the atoms involved in a particular bond. If there is no difference in electronegativity, that means zero, then in that case, what will happen is that the shared pair of electron would lie right in between the two atoms and strongly attracted by the nuclei of each of these atoms equally. However, there may be an instance that there is a difference in electronegativity, and as a result of this, the shared pair will be attracted more towards one of the atoms. As a result, that atom would become delta negative and the other one will become positive. So, for example, when we have like HCl, then in that case, chlorine is more electronegative. So, this will be delta negative, and hydrogen, on the other hand, would be delta positive. However, if the difference in electronegativity is very large, then in that case, this would result in the positive ion completely losing an electron to the atom, which will form a negative ion. Now, here I have explained it through the electronegativity differences through the Pauling electronegativity scale. When the two atoms are the same, for example, hydrogen bonded to another hydrogen, oxygen bonded to another oxygen through a double bond, nitrogen bonded to another nitrogen through a triple bond, then in that case the atoms are the same. So therefore there is no difference in electronegativity, and that results in a purely covalent bond forming. When there is some difference in electronegativity, for example in case of HCl, CCl, you can see the difference in electronegativity there is considerable, 0.9 for HCl, 0.5 for CCl, and so on and so forth. So that would result in a bond, covalent bond, but a polar covalent bond. On the other hand, when the difference becomes too large, then in that case, the positive ion, which is for example sodium here, that completely loses the electrons to the chloride ion, and potassium ion forming an ionic bond, purely ionic bond with fluoride ion, and so on and so forth. So here I have made a table to just explain my point further, that if the electronegativity difference is 0, then in that case it will be a pure covalent bond. If the difference is from 0 to 1.8 approximately, then it would lead to a polar covalent bond, and when the difference is greater than 1.8, that it ends up being a ionic bond. We have already learned that ionic bonds can also have some covalent character when polarization occurs. I have created another video on polarization in detail, so you can watch this. I'll give the link in the description box below. So polarization, is the distortion of the electron cloud around a negative ion by a highly charged dense positive ion. So when the charge density on the cation is very large, then it attracts the electrons on the negative ion. As a result of this, there is some electron sharing occurs, or you can say that there is some covalent character arises in an otherwise ionic bond. So now I hope you are able to understand that this is the continuum we are talking about. That on this end we have 100% ionic when the two ions are perfect spheres. On the other hand, 100% covalent is when the two atoms are completely sharing the electrons. Like, for example, hydrogen, hydrogen, or oxygen, oxygen. On the other hand, we have ionic bonds with some covalent character on the continuum over here, and there could also be a covalent bond with little bit of uh, polar character. So that, but it's not just these four. There can be significant, the shades of gray all over. So I hope I was able to make my point across and you were able to understand this continuum and you found this video helpful. And if you did this, then please like, share, and subscribe. And I look forward to see you on my next video. Thank you so much for watching. Bye. Take care.